So, in the last class we have seen what are Laplace transforms and how to find Laplace transform of some simple functions like 1 t or e ki power a t. So, what is Laplace transform of any function f t? Laplace transform of any function f t is nothing but 0 to infinity f t e ki power minus p t dt, and we are calling it f p, function of p. So, also we have seen that Laplace transform satisfy linearity property. So, now in this lecture we will find a Laplace transform of some standard functions. So, first, what is Laplace transform of t ki power n? So, Laplace transform of t ki power n, let us try to find it. Laplace transform of t ki power n. So, using the definition of Laplace transform, Laplace transform of t ki power n will be nothing but 0 to infinity t ki power n e ki power minus p t dt. Now, let p t is equals to some variable say z. So, it will be nothing but 0 to infinity z by p whole power n e ki power minus z, and dt is nothing but dz upon p. So, it is nothing but 1 upon p ki power n plus 1 integral 0 to infinity z ki power n e ki power minus z into dz, and this function is nothing but gamma function. So, it is 1 upon p n plus 1 gamma of n plus 1. Now, as gamma n plus 1 is factorial n when n is a positive integer, therefore, Laplace transform of t ki power n will be factorial n upon p ki power n plus 1 when n is a positive integer. Now, let us try to solve the two problems given below. Laplace transform of 3 t ki power 3 by 2 minus plus 5 into t minus 4 e ki power 2 t. Now, again by the linearity property of Laplace transform, this is nothing but 3 times Laplace of 3 by 2 t ki power 3 by 2 plus 5 Laplace of t minus 4 Laplace of e ki power 2 t. So, this is 3 into. Now, Laplace of t ki power n, as in the first expression we are having, it is gamma n plus 1 upon p ki power n plus 1. So, here n is not an integer, yeah, n is not a positive integer. So, we have to use the first definition of t ki power n. It is gamma n plus 1 upon p ki power n plus 1. So, it is gamma, here n is 3 by 2. So, it is 5 by 2 upon p ki power 5 by 2 plus 5 into Laplace of t, we have already seen that it is 1 by p square. Also we can obtain it here from here also when we put n equal to 1 in the in the second expression. So, it is 1 by p square minus 4 into Laplace of e ki power a t is 1 upon p minus a. So, it will be nothing but 1 upon p minus 2. So, now now gamma n plus 1, we already know it is n gamma n. Gamma n plus 1 is nothing but n gamma n, and gamma half is under root pi. This we already know. So, 3 into, now gamma 5 by 2. So, here it is 3 by 2 plus 1. So, it is 3 by 2 gamma 3 by 2 upon p की power 5 by 2 plus 5 p square 5 by p square minus 4 upon p minus 2 is equal to 3 into 3 by 2. Again we will use the same expression. Instead of n we have 1 by 2, because 1 by 2 plus 1 is 3 by 2. So 1 by 2 plus 1 is 3 by 2, it is 1 by 2 gamma 1 by 2. So 1 by 2 gamma 1 by 2 p के power 5 by 2 plus 5 upon p square minus 4 upon p minus 2. So it is nothing but 9 upon 4, and gamma half is under root pi. So it is under root pi upon p की power 5 by 2 plus 5 upon p square minus 4 upon p minus 2. So this will be the Laplace transform of this function. Now how to find Laplace inverse of the this expression p cube plus 2 upon p की power 5. So Laplace inverse of p cube plus 2 upon p की power 5. So it is Laplace inverse of 1 by p square plus 2 into Laplace inverse of 1 by p की power 5. Now recall the definition. Laplace transform of t की power n is given as gamma n plus 1 upon p की power n plus 1. So what will be the Laplace inverse of 1 upon p की power n plus 1 from here? It is nothing but gamma n plus 1 is a constant quantity, so it will go to the left and right hand side. So it will be nothing but 1 upon gamma n plus 1 into t की power n by that definition. So Laplace inverse of 1 by p square. So 1 by p square means n is 1. So when n is 1, so it is nothing but t की power 1 upon gamma 2 plus 2 into, now for this expression n is 4. When n is 4, so it will be nothing but t की power 4 upon gamma 5. So it is t. Now gamma n plus 1 is factorial n when n is a positive integer. So it is gamma 2, so that is factorial 1 plus 2 t की power 4 upon factorial 4. So it is t plus 2 t की power 4 upon 4 into 3 into 2 into 1. So 2 cancels out. So with nothing but 12 t plus t की power 4 divided by 12. So this will be the value of Laplace inverse of this function. Now how to find Laplace of sin 80? So now we will see how to find Laplace of sin 80. So sin 80, as we already know, is nothing but e की power iota 80 minus e की power minus iota 80 upon 2 iota. This is sin 80. Now Laplace of sin 80 using linearity property of Laplace transform will be nothing but 1 upon 2 iota Laplace of e की power iota 80 minus 1 upon 2 iota Laplace of e की power minus iota 80. So it is nothing but 1 upon 2 iota, as we already know that Laplace of e की power 80 is 1 upon p minus a. Okay, here instead of a we have iota a. So we will replace a by iota a, 1 upon p minus iota a minus 1 upon 2 iota. Again here instead of a we are having minus iota a. So we will replace a by minus iota a. So we will get 1 upon p plus iota a. So, we will take 1 upon 2 iota as common. So, in the numerator we will get 2a upon p square minus a square, 2 iota a, oh sorry. So, 2 iota will cancels out, so it will be nothing but it is p square plus a square. When you multiply these two, so it is a upon a square p square plus a square. So, this is the Laplace transform of sin a t, it is a upon p square plus a square. Now, so therefore, if you want to find out Laplace inverse of this function, this f p, so this will be nothing but sin a t. So, what will be Laplace inverse of 1 upon p square plus a square? It will be nothing but 1 by a sin a t. Now, Laplace transform of cos a t, in the similar way we can find out Laplace transform of cos a t also. So, what is cos a t in terms of e? So, cos a t will be nothing but e की power iota a t plus e की power minus iota a t upon 2. This we already know. So, to find Laplace transform of cos a t, again we will apply linearity property of Laplace transform. Laplace of cos a t will be nothing but 1 upon 2 Laplace transform of e की power iota a t plus 1 by 2 Laplace transform of e की power minus iota a t. So, this is nothing but 1 upon 2 Laplace transform e की power a t is 1 upon p minus a. Here instead of a we have iota a, so it is 1 upon p minus iota a plus 1 by 2 1 upon p plus iota a. So, when we simplify it, so we will get 1 by 2 into 2p upon p square plus a square. So, 2 cancels out. So, Laplace transform of cos a t is nothing but p upon p square plus a square. Similarly, Laplace inverse of this f p, p upon p square plus a square is nothing but cos a t. Now, now what is Laplace transform of sin hyperbolic a t? Now, we will try to find out this expression, to prove this expression in fact. So, what is cos hyperbolic a t? Sin hyperbolic a t? Sin hyperbolic a t is nothing but e की power a t minus e की power minus a t upon 2. This we already know. So, how to find Laplace transform of sin hyperbolic a t? Again we will use linearity property of Laplace transforms. So, Laplace transform of sin hyperbolic a t will be nothing but 1 by 2 Laplace transform of e की power a t minus 1 by 2 Laplace transform of e की power minus a t. So, it is 1 by 2 Laplace transform of e की power a t is 1 upon p minus a minus 1 upon 2 1 upon p plus a. So, when we simplify this, so we will get 1 by 2, it is p plus a minus p plus a upon p square minus a square. This p cancels out. So, it is nothing but a upon p square minus a square. So, this will be the Laplace of sin hyperbolic a t. Similarly, if we want to find out Laplace inverse of this expression, this f p, so it will be nothing but sin hyperbolic a t. Now, what is Laplace transform of cos hyperbolic a t? In the similar way, on the same lines, we can obtain the second expression, this expression for cos hyperbolic a t. So, what is cos hyperbolic a t? Cos hyperbolic a t is nothing but e की power a t plus e की power minus a t upon 2. This we already know. Now, Laplace transform of cos hyperbolic a t will be 1 by 2 Laplace transform of e की power a t plus 1 by 2 Laplace transform of e की power minus at. So it is nothing but 1 by 2 1 upon p minus a. Laplace of e की power at we already know, it is 1 upon p minus a plus 1 by 2, it is 1 upon p plus a. So it is 1 by 2, in the numerator we get 2p upon p square minus a square, 2 cancels out. So this will be the Laplace of cos hyperbolic at. Now Laplace inverse of p upon p square minus a square is similarly cos hyperbolic at, because if Laplace of ft is fp, then Laplace inverse of fp will be nothing but ft, that we already know. So this we have already seen, Laplace inverse of these three expressions we have already discussed. Now how to find Laplace of these two functions, these two simple functions? Let us see how to find Laplace of these functions. Laplace of cos 2t minus 3. So we know the Laplace of Laplace transformation of cos at. Laplace transform of cos at is p upon p square plus a square. But how to find Laplace transform of cos 2t minus 3, that is at plus b types? How to find out the Laplace of this? So it is cos a minus b. So cos a minus b is nothing but cos a cos b plus sin a sin b. Now cos 3 and sin 3 are the constant free from t, so it can be taken out because of the linearity property of Laplace transforms. So it is nothing but cos 3 Laplace transform of cos 2t plus sin 3 Laplace transform of sin 3t, sin 2t. So this is nothing but cos 3, and Laplace transform of cos 2t is p upon p square plus 4, and plus sin 3, and Laplace transform of sin 2t is 2 upon p square plus 4, p square plus a square, a is 2. So this is nothing but p into cos 3 plus 2 into sin 3 upon p square plus 4. So this will be the Laplace transformation of cos 2t minus 3. Now the second problem, and now the next problem, Laplace transform of sin 3t into cos square t. So Laplace transform of sin 3t into cos square t. Now we know how to find Laplace transform of sin 3t, but we do not know how to find out Laplace transform of product of two functions when both involves t. So first we try to break this function. Now sin 3t, what is cos square t? So cos square t can be written as 1 plus cos 2t by 2. Now this is nothing but Laplace transform of sin 3t upon 2 plus sin 3t into cos 2t upon 2. This can be written as 1 by 2 Laplace transform of sin 3t plus 1 by 2 Laplace transform of sin 3t into cos 2t. So Laplace of transform of sin 3t we already know, this is 3 upon p square plus 3 square plus, but again we have a problem here, how to find Laplace transform of this. So we multiply and divide by 2 in this expression. Now 2 sin a cos p, we know that it is equal to sin a plus p plus sin a minus p. So it is 3 by 2 p square plus 9 plus 1 by 4 Laplace of, it is sin 5t a plus b 2t plus 3t 5t plus this 3t minus 2t is t. So, now we can find out the Laplace of this expression. So, this is 3 by 2 p square plus 9 plus 1 by 4. Laplace of sin 5t is a upon p square plus 5 square plus sin t is 1 upon p square plus 1 square. So, this will be the Laplace transform of this function sin 3t into cos square t. So, now how to find Laplace inverse of this simple fp, this simple function. So, Laplace inverse of, it is p minus 3 upon p square plus 4. So, this is very simple to find out. You just split this into two parts, p into p square plus 4 minus 3 upon p square minus plus 4. Now, by the linearity property of inverse Laplace transforms, it is this into p upon p square plus 4 minus 3 times Laplace inverse of 1 upon p square plus 4. So, this Laplace inverse we already know, this Laplace inverse of this expression is cos 2t, because it is 4 is 2 square. So, it is cos 2t, because Laplace of cos 2t is p upon p square plus 2 square, that is p upon p square plus 4. Now, it is minus, now Laplace inverse of 1 upon p square plus a square is 1 upon a sin a t. So, here a is 2, so it is minus 3 by 2 sin 2t. So, this will be the Laplace inverse of this fp. Now, how to find Laplace inverse of this problem? Now, now here fp is what? Fp is p plus 2 upon p minus 1 into p square plus 4. So, this is a linear part and this is a quadratic part. So, how to find out Laplace inverse of this fp? So, this can be written as, now we will make use of partial fractions. First we will try to reduce into partial fractions and then we will try to find out its Laplace inverse. So, it can be written as a upon p minus 1 plus, now since it is a quadratic part, so in the numerator we will be having a linear term, linear in p. So, it will be something bp plus c upon p square plus 4. So, compare the coefficients from both the sides, we will, this implies p plus 2 will be equals to this into this, that is a into p square plus 4 and plus bp minus plus c into p minus 1. Now, we have to compute the values of a, b and c first. So, we can make use of, compare the coefficients from both the sides. Here the coefficient of p square is a, from here it is b, and here there is no term involving p square. So, a plus b will be 0. And the coefficient of p here is 0 and the coefficient of p here is minus b plus c, and here it is 1. So, it will be 1, and the constant here is 4a minus c, that here constant is 2. So, we are having 3 equations with 3 unknowns. So, we can find the values of A, B and C. So, A here we have already obtained actually. So, A is 3 by 5, B is minus 3 by 5 and C is 2 by 5. This you can easily compute by solving these three equations. Okay. So, once we obtain the values of A, B and C, then it is nothing but 3 by 5 times this, it is minus 3 plus 2 upon 5. Now, the Laplace inverse of this Fp will be nothing but 3 by 5 times Laplace inverse of 1 upon p minus 1 minus 3 by 5 times Laplace inverse of p upon p square plus 4 plus 2 by 5 times Laplace inverse of 1 upon p square plus 4. So, this is nothing but 3 upon 5. Now, Laplace inverse of 1 upon p minus a is e ki power at. Here a is 1. So, Laplace inverse of 1 upon p minus at is e ki power t minus 3 by 5. Laplace inverse of this is cos 2t. Okay. So, it will be cos 2t. A is 2 and here for this it is plus 2 by 5. Laplace inverse of this from this expression a is 2. So, it will be nothing but 1 by 2 times sin 2t. So, the final answer is e ki power 3t, 3 into e ki power t minus 3 cos 2t, these two cancels out plus sin 2t upon 5. So, we have seen that how we can find out Laplace transform of some standard functions like sin at, cos at, sin hyperbolic at or cos hyperbolic at, and using these Laplace transforms how we can find out Laplace transform of some functions or inverse Laplace transforms. Thanks.